just a basic introduction of some new software packages. Some of them we've been using up here in the Harrisburg office for a while now. My understanding is they're being rolled out company-wide, at least to land development. And we're here just to try to tell you what we know. We're by no means experts, but we do, been using them for a while and know a little bit about some of the tricks of the particular programs. The three programs we're going to be looking at covering today, two are made by a company called IntelliSolve, and they are HydroFlow Express and HydroFlow 2005. And there's also another package you'll be getting called HydroCAD. So it's just a brief introduction of the programs, what they are. HydroCAD is really a stormwater management program. You can think of it as a replacement upgrade to like VT Push'em. It's very similar to the Hasted's product Pond Pack, if any of you are familiar with that. It's pretty powerful. It can model ponds in series, can do a lot of things. And Charles Smith, I think, will be covering that here a little later in more detail. The other program we're going to talk about is HydroFlow 2005. And this is really a storm sewer design and a modeling package. It can calculate inlet capture. It can, be used to size the pipes. It'll count for bypass that's not captured in your system. It'll even calculate hydraulic grade line for you. So, and I believe Brian Gregg is going to be covering that one in a little more detail. The third one is HydroFlow Express, and for those of you that are familiar with some of the Hasted's products, it's similar to the combination of maybe Culvert Master and Flow Master. And you can use, of course, the design culverts, and you'll find that in the culvert section it's very much like HY8. It's just a little more, I guess, user-friendly, if that's the word. The input and Windows-based, it's just a little more user-friendly than the HY8 DOS program. You can also do channels with it, open channel flow. It will also do individual inlet capture calculations. And because it's made by the same company as the HydroFlow 2005, you'll see a lot of similarities in that as far as, the inlet types, all that kind of stuff. And also can do some simple hydrology, just calculate some peak flows, things like that. And it'll do some weir calculations if you just need something quick on the weirs. I'm going to be covering the HydroFlow Express. It's really very basic, and I think I'm going to just start with the culverts up here. You can see, here's just the drawing to sort of tell you what everything is. This is your input screens. I'm assuming most people are familiar with HY8, and if you're not, both of these programs, or both of the parts of HydroFlow Express, are really intuitive. There's not a whole lot of tricks to them. The only thing I would caution you here, the first time I used it, slope in percent. That actually means percent. You don't put in 0.02. They're not talking about feet per foot. They want 2%, 1%, 1.5%, whatever it is. There's some of the items here are relatively easy to do. I'm just going to punch in some numbers here, and we'll just see how it works. I'm just going to put in some random numbers. Hopefully everything goes well for me. You can see some of these have like little pull downs when you click on them, and you can choose from the different things. This would be just a typical, I'm just trying to put in something that would be similar to a typical road cross section at a low point where the culvert would be. And then down here you can see you have a choice of You know, you can put in a fixed tail water if you happen to know that for some reason you're discharging into a stream directly or a pond of some sort. You know, you got your choices of the crown, normal, critical, whatever you want to choose. Then you just click run, and it actually builds the segment you described over here on the left, you know, and then also shows, you know, your water surface elevation is under inlet control under this scenario. You know, here's if you're having overtopping of your road, it would show up in here. Gives you your velocities, you know, all kinds of the hydraulic rate line, all kinds of information. And then if you want to change something, try a different size. Oh, okay, hey, maybe that 15-inch culvert isn't big enough. Let's try something bigger. You just go back in here and change it again. You know, go to 18 and click and just click run again, and it just, you know, does it that quickly. So I think that one's pretty simple. There's not a whole lot to that, and you'll find, if I go over here to the channels, you know, it's same type of input over here on the left. And the only thing is you want to choose your you know, your channel geometry up here. I'm just going to choose a trapezoidal channel because that's what I almost always build. And again, it's just putting in input, side slope. Anything you have to remember here is to put a comma between the two different side slopes, and it'll take it right away. The only thing I found different from this than Haysted's methods is when you get in here to compute by depth. This one's a little bit different in that it's not quite as easy as the Haysted's Flowmaster to, if you're trying to do like for ENS and varying the end value with depth, it becomes more trial and error than the Haysted's. The Haysted's is a little bit easier because the output it gives you is just a little bit, I found a little easier to interpret. But you know, this is pretty it's not hard. It's simple. It's you know, you guys are, you know, engineers and designers. You can figure this out. It's not that hard. I just put a random invert. I don't even know why they have that in here. I don't know that you have an invert of a channel. Channel is, to me, is a longitudinal item. I don't know that it has an invert, but you know, I just put in 100 just because it's a number. And of course, here's your pull down. You can add like a known Q, known depth, or the and here you go. You know, here's where I'm talking about your trial and error. You can see that, you know, as the depth goes, your Q goes up, your area, but you're having, you know, if that's N is varying with depth, you're really going to have to go back in here and play with this number based on, you know, your wetted perimeter and your, you know, those kind of things. Other things here, just some of the other tabs up top here. There's your inlets. A bunch of different inlets here. I would say in Pennsylvania, they use a little bit a different terminology than we do. You know, I would call a type C inlet a curb inlet. Well, there's your sample curb inlet, and you can see that's something different than what we call a type C. What they call a curb inlet is merely a hole in this curb. Doesn't have a grade at all. So you're going to need to use the combination inlet to try to model the type C, and a type M is more what we call a grate inlet. Some of these others, you know, they're just, I've never used them personally. So if we go here to the type C, again, I'm not going to go and input everything, but you can see, and Brian will probably touch on this some more because he's going to do the same. You know, these are the same type of information you put in the HydroFlow 2005. So it's the same information, and you can just calculate if you have individual inlet capture or one you're worried about or something, as opposed to the whole system. And maybe you can just use this program. The hydrology is just straightforward, you know, rational or SCS or modified rational. You know, there's nothing there that you can't do with a calculator and a pencil and paper. And pretty much the same thing with the weirs here. you just have maybe some different geometries than you might have. Might be a little easier to use this than looking up your weir equations and your C's, your weir coefficients for the different types of weirs. But really, HydroFlow Express is just a real basic, quick calculation of some things. It'll save you some time. Like, if you're doing a calculation, a culvert calculation by hand or something, they can be quite time-consuming because they're really trial and error. And this will save you a lot of time on that. I don't know if anybody has any questions on this one.
Yeah, I have a question.
Sure, I'll try to answer it.
Okay, back on the channels, can you talk about the increments?
Yeah, that is here with your depth increments. You can see I gave it, just assumed a 1 foot depth, and if you look here, it gave me 10 increments, so it divided that depth into 1 every 10th of a foot for that depth, because I was calculating by Q versus depth.
Okay.
Okay?
Divide your depth.
It just divides your depth by whatever increments you have in here. If I put 20, this column would have went, every, 5,000 or 500ths of a foot.
Gotcha. And in the inlet types, does it have just throat inlets or a way to customize in a custom type inlet?
Boy, not that I know of. I think they're pretty much stuck with what they have here.
Well, in HydroFlow 2005, there's a generic inlet where you can give it size and shape properties. I don't know if this has the same option. I would think
I did not find it in here, but it very well could. But I haven't really had to do that yet with this product, so I don't know.
Okay, so what you have on the screen right now is just a throat inlet. So
Yeah, really, that's probably it. So you just have to look at that.
But if you have different types of inlets, you might have a need to define something custom.
Correct. And I'm not sure you can do that in this program or not. I've never had to, and I don't know if it does it or not. But as Brian said, that the HydroFlow 2005 will let you do that.
Okay.
The only other thing is up here, you can see the IDF button.
Okay.
This is just the sample. We are in the process of, getting the IDF curves inputted for all the various regions of Pennsylvania, straight from the PennDOT book. So they will be made available to you here probably. Actually, I think Mark is saying here they're available. He's going to them. They're on the F public drive down in, where are they, Mark?
If you go to F Public Network Apps, and you actually go to HydroCAD, and then go to IDF. So far we have Region 4 in there, and that should be on everybody's server. As we get 1, 2, 3, and 5, we'll put those in, and we have to check them, of course. And we'll get those out, and then it'll be company-wide.
Under culverts, can you do box culverts?
Yes, there is that option. If you go down there to the shape, that comes as one of those pull downs. If you click on that, you can see there's arch, box, circular, or ellipse.
Yeah.
We're going to assume that we have a DXF file created and that we have that XML file that contains the pipe information created. I'm going to go through an example of pulling this into HydroFlow and then working with it to design your storm sewer system. Again, HydroFlow is a program to design storm sewer systems. It's not really for designing detention ponds or anything like that. So I'm going to go ahead and open HydroFlow here. We have a blank slate, and we'll just start with that. The first thing I usually do is pull in that DXF file so I can see what I'm working with. So you just go up to File, Import, and import background image from DXF. You're doing exactly what it says. I'll navigate to my example, which is different than what Mark was working with, but it's the same idea. Okay, so here's the DXF file that the CAD user or myself would have exported from CAD. We'll select that. Okay, I'll zoom in here. So you can see, this isn't the cleanest example, but it shows the streets that we have, and then it shows the green lines are where the storm sewers are going to show up when I pull them in to the program. So it's nice, if you do have somebody export a DXF file for you, always have them include the line work for the pipes so that you can see where the pipes should be when you pull in the runs. That makes it easy to see if you've missed anything. So the next step is actually going to be to pull in these pipe runs. Same idea, you go up to File, Import, and you do Import Land XML. Again, you navigate to that XML file, and then hit Open to sort of unlock it. And that's going to show you over here all the different pipe runs that were exported. I think this one even includes sanitary, but we won't really get into designing that. Mark mentioned this before. You want to try to pull in, you want to try to select all the individual pipe runs that make up like one network, from the upstream most points to a single outfall. You want to try to select them all together, because in CAD they might have been set up as separate runs, but if you select them all together and bring them in together, HydroCAD will link them all up so you just have one outfall. If you were to select them individually, you'd get multiple outfalls, and it would get a little bit difficult to reconnect them. So I've already decided which ones go together. So I'm going to just highlight those particular runs. Once you do that, you have to come over to the right and select your import options. I don't even know why they make you do this, but you have to click that you want to bring in the selected pipe networks. So just remember to click that box or this isn't going to work. And then you just hit Import. As you can see now, it has pulled in a single run. It flows down this direction to a common structure, and then out into where we have a detention pond here. One of the things you also notice is that all the structures come in with sort of made-up names that HydroCAD gives them, HydroFlow, and they also all come in as manholes. So the next step, unfortunately, I haven't figured out a way to get around this. You have to go in and change those structures to the names that you want and the type of structure that you want. So just for example, I usually start at the upstream end of my system. You select the line, you select the pipe basically between two structures, and then simply hit, let me escape out of that. Select the line that you want, and then hit Data. And that's going to bring up what they call the Data Dialog box. This is all the information for the pipe that you're looking at between these two structures, and then also the structure on the upstream end. So there's two tabs here. First one is for the actual pipe data, and the second one is for the structure itself. So we'll just start with the pipe. And as you can see, and as Mark told you, the real benefit to doing this is it has pulled in the line length from CAD. It has pulled in the rim elevations from your surface. It has pulled in whatever line size and shape and information the CAD user gave it. Now typically, the CAD user, I'll just have them give all the pipes in the system, 18 inches, or they'll just put in something as a placeholder. But the more detail they put in, that will show up. Usually we just end up redesigning it though. But the real benefits are you get the pipe length, you get the the rim elevations from your surface, and of course you've got the alignment set up, angular-wise in plan view, the way it shows up in CAD. This prevents, making errors transferring between the two programs. So once you have your pipe screen, you need to give it some flow information, and you can do that down in this bottom left-hand corner. If you have a known flow, you can just give it that. Otherwise, it can do some basic hydrology. So you can give it a drainage area and a runoff coefficient. And if you have multiple runoff coefficients, you can actually set that up with different sub-areas and different coefficients that go along with that. And it'll compute a composite runoff coefficient. You can also give it an inlet time. This is your time of concentration. For storm sewer systems, it's often 5 minutes for each inlet. So you can put that information in, and it'll calculate, once we set up an IDF curve, it'll be able to calculate for each storm the runoff to that pipe so that you can size it. You can also come over to the right and give it as much information as you want. We'll talk later about how HydroFlow can actually do some design for you. Right now we have some inverts that are in there. I don't know if they're going to be our final inverts or not, but there's numbers in place. Once we have that set up, you may want to rename the pipe again, whatever naming convention you're using. And then you want to switch over to the inlet. Again, when using HydroFlow, it's going to bring in every structure as a manhole, so usually you'll have to change that. And here you have different options for different types of inlets. And these also mimic that HydroFlow Express that Eric went over earlier. So you've got the curb inlet, which is just a hole in the curb. You've got grate, which is your standard type M. You've got combination, which is your type C. And then you have a generic inlet, which you can give it whatever properties you want. You also have things like head walls, drop curb, other structures. So usually I'll switch this to, say, a combination inlet. And now it opens up all this other information that was grayed out for a manhole. And so you're going to need to start filling that information in. Important information here is whether your inlet's on grade or in sag. If it's on grade, you're going to be able to tell HydroFlow where any bypass flow might go. And that's another nice feature of the program, is it automatically recalculates the flow to each inlet based on upstream flow that might have flowed past an inlet that couldn't capture everything that was coming to it. So if this one's on grade, I'm going to tell it which line is downstream. So for example, if we're working with this structure over here, that line is number 13, so that's the number of the pipe. If it were to bypass, say, this structure here, it's going to flow into line 11, because it's going to go to the next downstream inlet. So I would come over here and tell it that the next downstream pipe is line 11. And you'll have to do that for everything that's on grade. If it's on sag, it's going to assume that, well, we don't have enough information here, but if it's on sag and you click this button here, it'll assume that the inlet captures everything if there's no bypass. Again, basic information on the dimensions of your inlet are over on this side, and then you also want to give it your roadway information so it can do gutter spread calculations. That's another thing it'll automatically do for you. Tell you your gutter spread, inlet efficiency, how much each inlet captures, that sort of thing. So you need to have your roadway cross slope and gutter cross slope, any localized depressions. Sometimes we sump our inlets an inch or two. The width of your gutter and the longitudinal slope of your road, and then the Manning's number of the road. You can enter all that information here and then move on to, why is it not letting me do this? Oh, it doesn't, it's a manhole. It doesn't like that I did that, because it's offsite. Yeah, I'm just gonna set this to offsite. This is, we're working with raw data here, and I haven't filled in all the information yet, so the program's not real happy about that. So what you do is you go through and you do that for each of these structures, defining them as manholes or inlets, giving them the information for the flow into each pipe, giving them the roadway information, and through the miracle of preparation, I have one that's already done. So here I've gone in. Hey, awesome. Let me reload the DXF. Yeah, worked upstairs, it's not working here. Okay, minor glitch there. So now, this is an example of where I've gone back through and reconfigured all the structures as inlets. I believe I gave, we've got the roadway information, your typical 2% cross slope for the road and the gutter, 2-foot gutter width, and we've got a road that's at 5% We've got a grate inlet that's on grade, and the nearest, and I've already got the downstream target identified for any bypass flow. Then in the pipe, you'll notice that I've kept the line length that we got from CAD. I've kept the grate elevations that we got from CAD, but I've deleted anything about inverts or slopes of the pipe, because we're going to design that as we go. And I've also put in information so that it can compute a flow. We've got a drainage area of 0.3 acres, and a runoff coefficient, and typical 5-minute time of concentration.
All right, I have a quick question.
Yeah, go ahead.
If you put in, say you have a subcatch that's catching water from off-site, say the time of concentration is 15 minutes.
Mm-hmm.
If you enter the values in with the area, the C value, and that 15-minute TC for that one inlet, will it use, now that leg has a total time of concentration of above 15 minutes, even though the rest are 5.
Right.
Does it add does it cumulatively add the time of concentrations as it goes down through to the flow lengths? Opposed to if you just enter a known flow, it can't do that, it just has that flow and that's it.
For conveyance, it does add the time of concentration.
I think you have to tell it when we're going to talk about that in a minute. There's different design options when you're actually running this, and one of them takes into account travel time through the system when it's computing the flow, like at the next downstream pipe. And I think that if you select that option, it's called enhanced design. We'll see it in a minute. I think it will take into account travel time in your pipes. So if you have a very long pipe run, or perhaps if you have off-site areas that have long upslope drainage pads, you might want to use that. Usually, it doesn't make a difference because the travel time in your system is so negligible. Anyway, right now we've got all the information we need to begin designing our system. The other thing you want to do before you start doing any design is set up your design codes. Now, these are things that are going to apply across your entire design. So you can tell HydroFlow that you want to limit the design to certain pipe sizes. So maybe your ordinance says the minimum pipe size is 18 inches, and you don't want the program to either insert a 15-inch or let you insert a 15-inch pipe. So you simply select the minimum pipe size we're going to use for this is 18. You can also put in a maximum. You can do other things like if you have a certain velocity that you have to meet, or minimum slope, often use 0.5% for minimum slope. Minimum cover, often 1.5 feet. You can put all these things in, and then when you use any of the automated design features of HydroFlow, it's going to respect what you told it. Another nice thing is to put in a standard drop at each inlet. Sometimes we use 0.1 or 0.2 feet. You can tell it whether you want to match crowns or match inverts. There's a lot of things you can do here to have the program do some work for you. So these are the design codes. The other thing you need to do is set your IDF curve. Again, this looks very familiar to what we were doing with HydroFlow Express. You need to load an IDF curve for your region, and then the program, based on that time that you gave it for each inlet, it's going to use this. It's going to use the rational method, and it's going to compute the flows at each pipe. So those are the last sort of 2 steps that you need to do before you're ready to run. And now we are ready to run our program, I hope. So you go up to the Run option, and it's going to ask you how you want to run it. So it's going to ask you what storm you want to look at. You can pick anything from the 1 to the 100 year. You can also pick different options. I think today we're probably going to just look at analysis with design. And the nice thing is it gives you a description over here of what these options are. Analysis with design is your basic design tool. It computes the overall system, designs the pipe sizes where you need them to be designed, like I left some of them blank. So it designs as required. And this is the typical thing that you're going to use. We just talked a little bit about enhanced design. The only difference is it's going to consider the time of concentration over the length of the system. Instead of just going 5 minutes at each inlet, it'll look at travel time through your system. Full design is something where the program is actually going to ignore any of the information you gave it except the layout. It's going to and those top of grates. it's going to go in and it's going to take that minimum cover you gave it, minimum slope, and the pipe sizes that you limited it to, and it's going to design the system for you. It's a little dangerous because it can overwrite maybe information you wanted it to have. Like if you have a known outfall elevation, it may overwrite that. And capacity only means that it's not going to use the hydraulic grade line as a design. It's just going to design everything for maximum full flow through each pipe. You might want to use that if you're trying to analyze an existing condition, something you're not designing, but where you want to know what the full flow of an existing pipe is. But typically, you're going to use analysis with design. And another nice feature is I like to use the interactive feature. That lets you go through pipe by pipe and design it, and it automatically recalculates what's going on in the system. We'll do an example of that. And then finally, you need to give it some starting information. So this is my downstream end. You can see that represents this area down here. Drainage manhole 1 to end well 5. This is drainage manhole 1. So I'm going to tell it my downstream invert, and I'm also going to give it some place to start with those hydraulic grade line calculations. Here, I've actually given it an elevation, and that elevation represents the tailwater in this detention pond. You could also, if you don't have a detention pond, you can give it, crown of the pipe, normal depth, critical depth coming out. There's a bunch of different options here, but you do need to tell it something, and you want it to be representative of your situation, especially if you have a detention pond. So we're ready to go and start the design. What it's going to do, this is the interactive feature, and this is one of the nice things about HydroFlow. It's starting me at that downstream end. I like to actually start at the upstream end, so I'm just going to go all the way up. And this is sort of it's already filled in some basic information for me, and I can go through here and design my system on the fly. The red line represents the hydraulic grade line, and that's what we're designing around. We want to make sure that stays in the system. It doesn't pop out of any manholes or inlets. So you use the bottom of the screen to do your design. It's going to tell you what your upstream and downstream top of grates are, and that was pulled right from the surface in CAD. That was what we imported with the XML. On the upstream end, this is the invert of my pipe. So if I select this, it's a little hard to see on the screen, but that turned yellow, so that means I'm working with this number here. And I can move my pipe up and down, and it's automatically telling me the new slope of the pipe, and it's showing me the effect on the hydraulic grade line as I do that. So I want to, and up here it's telling me how much cover I have left on that upstream end, because I'm working with the upstream invert. Some shortcuts, you can select this, and then this button over here just says adjust to minimum cover. You can see the little dialog that popped up. So in the codes, I told it my minimum cover was 1.5 feet. If I click this, it automatically brings it up to 1.5 feet. Then I can look at the downstream end of my pipe, and I could do the same thing. It brought it up to a minimum cover of 1.5 feet, but I need to adjust the slope. So I can then pull that down until I get, say, an acceptable slope. That's about 1%. And sort of an odd interface, but the way it works is these arrows over here for moving your pipe invert up and down move in increments selected over here. So if I want finer increments, this will move it in hundredths of a foot. So you can see it's moving much slower now, or if you need to move a large area, you can actually move in up to 1 foot increments. So it's pretty simple to use. You have a question?
Can you just input that elevation you want?
No. Unfortunately, you cannot just type in the elevation you want, which would be nice, but we're assuming that we don't exactly know that yet, or it would have already been in CAD, or you could have put it in when you were putting the basic information in for the pipes. If you knew it, you could have put it in there. But once you get in here, it's assuming you're designing and you don't know exactly what elevations you want. So let's say I'm happy with that. I've got 0.5%. I've got my minimum cover on the upstream end. You just move to the next downstream pipe and move along doing the same thing. I usually just use this minimum cover to pull that up, and then click down until I get the slope I want. Say, I don't know, I think it looks like 1.5 or 0.5%. The nice thing is, again, here we've already got a pipe that's been designed. It's kind of grayed out. That was our upstream-most pipe. Now I'm working with the next pipe downstream. Another quick shortcut. Say I just want to match crowns. That's what this button does for you. It matches the crown. Boom, there you go. Next one down, minimum cover. So you've matched the crown. You've got minimum cover here of 1.5 feet, and you have an acceptable slope. You can see the hydraulic grade line staying in the pipe. You can then look upstream and see, make sure that that didn't make it pop out anywhere. And you can work down doing the same thing. So once you get good at using the interface, you can design very quickly here. And remember, it's always recalculating upstream that hydraulic grade line, so you can see any effects that you've done. Again, in here you can also change pipe sizes. Same thing, you just select the size of the pipe. If this pipe was, say, too small, you can increase the size of the pipe. It's going to tell you both here and on the pipe itself what size you're at. So again, you're designing on the fly, and you can just keep going down through your system. When you get, say you've designed everything that you want, and you just want to see the results, you can just hit finish, and it'll finish out any design for you based on those design codes that you gave it. And you've got a completed design. And then you can view it by looking at different profiles. And I don't know what we're going to get here because I didn't really go through designing everything. But for the profile, this is for sort of checking your results. It's starting me at my downstream end, and I just pick how far up I want to go. These numbers here represent the individual pipes, and this over here, like I9 to I8, that's a name I gave it. So you can do that, and again, you've got your ground surface in green, and then you've got your pipes in here, and you've got your hydraulic grade line that's going up through. This looks like a pretty good design. It doesn't pop out of any manholes or inlets. So you basically got your design done. You can view the results here, and they have some standard tables that are set up that you might print out to put in your stormwater report. Typically you use the DOT table, which has a lot of information, but it's telling you everything you'd need to know that we would typically set up like an Excel spreadsheet, and you can just print it out. There's also an inlet table. This is going to give you information on gutter spread and things like that. Here you go. Here's your inlet spread, gutter depth, gutter spread. All that information has been calculated for you. And if you don't like any of the tables up here, you can actually define one with any variable that the program has. So this is giving you, I believe this is every variable that the program has, and you can just go through and say you don't need that one, you can just kill it with the X, or you can redefine to any variable the program computes. So you can set up custom tables if you want. That's basically the basics of a design in HydroFlow. Some of the tips, again, when you pull in the information from the XML, you're going to have to re-evaluate each structure, tell it what kind of structure it is, because it's always going to be a manhole when it comes in. Another thing that you want to do is save your work often. This program only gives you one undo. So often before I run something, I'll do a save as, because it's not very forgiving if you make a mistake. I've also found that it's not the most stable program in the world. They're making it better, but I was playing with it this morning and it crashed on me. So I do save my work pretty often. That's about it.
I have a couple of questions.
Okay.
I was wondering if you could, like the help menu seems is really good on this,
Mhm.
and I go to it all the time to get refreshed, and it really seems to explain, for example, like what the different inlet types are.
Right. Yeah, that's a good point. They have a pretty good, this is an example, they have a pretty good help menu here where it actually shows you diagrams of the different types of inlets. So if you don't know exactly what HydroFlow means by a certain kind of inlet or what the certain dimensions are that you're putting in, you go to the help menu and it's pretty clear. Go ahead, Charles.
that wasn't really a question, but anyway.
Okay. Well, I thought it was a good thing to demonstrate in case people have questions about that sort of thing.
I wanted to see if you could show also how you can view the inlet spread sections
Yeah.
by the plot.
Okay. There's other there's other sort of ways to view the information. I demonstrated a profile before. There's also what's called a plot, and that looks at one pipe or structure, and it gives you a little bit more detail than that profile view. You can only look at one pipe at a time, and you can either look at a profile of pipe between two structures. You can look at an inlet. It's kind of an interesting view. It shows you this inlet. It's telling me that it's inlet 6 right here, and it's showing me an example of what the gutter spread sort of looks like based on the roadway information we gave it and the type of inlet that it is. So you can see right away if you're going to have any bypass flow, because we've got blue going past the inlet, and it's telling you right here it's bypassing about half a CFS. It also shows you the width of that spread, so you sort of know what those numbers mean in the table with a graphical representation of that.
And the last thing I had was the global edit feature when you're designing in plan view.
Okay. Yeah.
If you go in and enter your Manning's End at .013, and then you discover that the ordinance lets you use .012, it may tip the balance in your favor if you're trying to get something to work. And you can go into the plan view and globally edit values.
Yeah, I'm trying to, let's see. Go under data, and let's say, these are set up so that all the pipes have a Manning's number of .013. Maybe they're concrete or plastic. But like Charles was saying, maybe you have to use a different material, or you find out that you can use a different Manning's number. Maybe we can use .010. I've changed it for this structure, for this pipe, but I believe if I hit global,
You just hit apply to all.
I can hit all, and it's going to apply to every line in my project here. I hit OK. It says global edit complete. You can see the Manning's number is .01 here. It's .01 as I cycle through all these other pipes. So that's a great, I'm glad you brought that up. You can, something like that where you might want to change it for every pipe, you can do that without having to go to every pipe.
Does that hold the same true for pipe sizes and all the information in there? Like if you go in there, or is it just
I
Manning's?
think you can change anything.
I
Like
think
you
it's anything. I've only used it for Manning's, though.
you can give them all the same inlet break if you wanted to. I don't know why you do that, but you can do it.
Well, you can get them all the same type.
Yeah.
You go to junction.
I never thought to do that, but I think, if you come in and everything's a manhole and almost all your structures are grate inlets, or say, let's change it, let's say they're all, curb inlets, I think you could hit global, hit all, hit OK, and it might be an easy way to make all those changes quickly. You can see they're all curb inlets.
Same thing for road cross-section, gutter,
Yeah.
local depression, that's all.
Yeah,
It's going to be a pain for a while.
you can change all that globally, or I think you can set that up just
default.
yeah, you can also set that up in your design codes. So there's multiple ways to change information for multiple structures. Other questions?
The final, I'll stop now, but the final thing is just that I found that if you're trying to do a yard inlet, the best representation of that is a drop grate inlet,
Okay.
because you can set the slope down to it. None of the other ones really represent a yard inlet like a drop grate does. And that's something that you can look up in the help menu too, just under inlet types.
Yeah. Okay.
And that's all I have.
Cool. Yeah, I had some.
Again, with your IDF curves, you go to open and go to the same location on the F, public network apps. Again, we're going to go, it is HydroFlow, we're going to store all the IDFs in the same location, and they'll be in there. I think that was it. I just wanted to.
Somewhere on the display, it's showing you which storm you're working with.
If I heard you right, you wanted to see, is this what you're looking for?
Right, it's on, you have to open that box. storm you're running currently.
Yeah, you're gonna have to tell it which storm you want to look at each time. It won't run like multiple storms. You can't just say run and have it run all of them. You'll have to rerun your information for each storm. And then that'll update, that's going to update your results for each storm.
Can you see the results of each storm?
No, you can't like save that 2-year result and then run the 100 and look at that and then go back to the 2. You have to rerun it each time.
And every time you make an edit, like if I'm in this table and I make an edit in here, I have to hit run again.
Yeah, notice the green light here? It's subtle, but that means that this information in these tables is good. It's based on a run where nothing has changed since. If I were to go back to my plan and decide to change my road slope to, say, 3%, and I go back into my results, I got a yellow light, which means you should rerun your information because something's changed and this data is old. So that's another thing to watch out for. If you change anything, you're always going to want to rerun it.
Something that I've noticed too is I like to double click a lot of things. And if you double click on these pipes, it will open this dialog box. But you've got to be really cautious because it has a tendency to want to rotate the structures, and it can rotate your entire line. If you do like that, just come up here and hit lock on all your structures, and then you can, it used to work. This computer has double-click issues because whenever you're recording something, the double-click gets goofy on you. But if you double-click the pipe, then it will open up this dialog. It's just the point I'd like to make is to lock that stuff. It's very easy to, if they're not locked, to change this angle. You double click it and your whole thing rotates off base, and it's like, whoa, what just happened there? Yeah.
Don't you lock every pipe or is that global?
I think that's global. Yeah. That's something. And that doesn't, I don't think that affects your design. It just locks it.
Yeah, it's just telling it what you can pick. Like you can lock the nodes and then change the rotation of a pipe and things like that. We didn't really get into editing your system, which is sort of a whole other lesson in itself.
Next thing we're going to cover is called HydroCAD, and this is, you can think of it as more of a graphical VT pusher and more customizable parameters and options and things. And you would think it has something to do with AutoCAD, and it actually doesn't. It's not a drafting program whatsoever. It's just what they decided to name it. So just explain what I've got up here. This is an agenda, a small agenda, and I'll scroll through it as we go through what I'm talking about. And when you replay this, hopefully that'll help out. This is my email address. You're welcome to email me or give me a call if you have any questions. Mark Spatz also knows quite a bit about this, and Bill Schnorr and Brian Gregg, among others.
We talk about HydroCAD too much. I think we all know a little too much about it.
And Eric Hershey's included in that too, but I haven't had permission to put their email addresses up here, so I'll just leave them off for now. All right, so basically, with HydroCAD, you have the same capability as you would with VT Pushem, only it's a little more powerful because you can set different parameters, and it's a little more customizable, and it's got a much cleaner user interface. One of the main advantages, I think, over VT Pushem is that the file management is much simpler. Like I have a project with 9 basins on it, and I have 4 stormwater files as opposed to hundreds that I would have for VT Pushem. And I run out of creativity after a while on naming conventions. And then when I go back 6 months later and try to figure out what I did, it's quite a process to figure out how I name the VT Pushem files. So that's one major advantage. Another is just that it has a really nice graphical user interface, and I'll show you that shortly here. And like I said, it's customizable for different parameters that you might want to set with stormwater. It's easy to edit too, and you can go in and really make changes on the fly. I suggest doing a save as before you do that though. And what's really nice is it has a steep learning curve. I mean, you should be able to knowing stormwater, you should be able to take this program and be designing in a couple hours. But what I'm going to do is just get started with an SCS example, just a basic project, just to really show you how to get off the ground. So you just click in the field, and we're going to create a project, and I'll just save it to the desktop here. And just call it test. And if anyone has any questions along the way, just shout them out. Feel free to just go ahead and speak up. And if anybody in the room here has any suggestions while I'm going through it, just speak up also. But to start out, just like in HydroFlow, you have global settings, and you also have individual settings for each feature. I'm going to go ahead and set up the project for SCS, and there's two ways to get to the global settings. One is this icon right here, which is calculation settings. You can also go through the menu, which is settings, calculation. Same dialog box pops up. This program uses TR20. I'm not really sure what SBUH is. Maybe some other stormwater guru knows what that means. And you also have the choice of rational, but we're going to try TR20. That's the more complicated version of TR55, basically. TR55 is a quick hand method, supposedly. So I'll just click on that, and these pop up with defaults, and you can study what you want to choose out of those. I always leave them as default. This is storage indication and transportation, and this is storage indication. So we'll go with that. You have different tabs up here. These change depending on whether you use rational or SCS. Rainfall is, like in this area we have a type 2 storm. You can look in your TR55 book for the rainfall depth if one's not supplied by your ordinance. So we're going to put 3 inches for the type 2 24-hour. AMC is I guess that's your antecedent moisture condition. I usually leave that alone. If you want to get fancy, you can look up what that's supposed to be in TR55. Storm duration, 24 hours. I think that's the standard use for TR55. Back-to-back storms. I suppose if your reviewer requires you to do back-to-back storms, you could set that up here. I've never personally done it. Rainfall event. You can name it, I guess, if you want to. I've personally never done that either. And you can save. I guess it's a scheme you can save.
Yeah, you're going to want to save. You're probably going to. I do name those because if you're running multiple rainfall events, the depth, your rainfall depth there, that's the 2-year depth. You're going to have to do the 2-year depth, the 25-year depth, the 100-year depth. So I do name them.
Okay.
This is where you can import the IDF information and then set that up.
In the rational scheme, we would.
SCS, you have to enter it in.
So we'll save that one. I guess I can go ahead and enter a couple of rainfall depths. I don't have the TR55 book with me right here, so I'm just going to guess. Just 400 inches. So that's going to be...
Put 5 here, put 5, and then YR, and then you'll see.
And then, yeah, okay, so that, for our purposes, that's good enough. Time span, there's a lot of room on either side of your SCS hydrograph, and you may not want to show that in your tables and in your, there's a lot of room on either side of the peak that just isn't relevant at the end of the day. So you can you can tweak your time span to show, to omit the first 5 hours or maybe omit the last 5 hours. It's basically personal preference. Time increment is just, how often it takes a sample. So I'll just leave that as default. I often set it at, I often set it at that or 0.1 if I want to be a little less precise. Reports is how your data is displayed. This is something you'll just have to tweak on personal preference. Use reduced time span for hydrograph. That, if you're printing this out, it will, okay, yeah, this tweaks the report, so, okay, here's what it is. Time span is actually how it calculates the storm. Reports is how it shows the storm when you print it out. So that's the difference. You can do a reduced time span for plots and tables, so you don't end up with as many pages in your report. custom elevation. This is stuff that I haven't used. I don't make full use of all the different reporting features, but it's something you can play with. I'm just trying to cover the basics here today. Unit hydrograph, you can choose SCS, and there's a couple of other choices. I always just use SCS. And if you just want to view the unit hydrograph, that's basically what it looks like. And you can close back out. Well, you can also view, you can compare them with checkboxes. So that's that. Advanced, you can set that's your initial abstraction over S ratio. You can set that up if you want to. Minimum TC, I usually set at 5 minutes. It tends to reduce error messages if you already have a 5-minute TC set in there. And this checkbox is to round internal curve number and C values to match the display values. That's nice because it won't cause inconsistencies between what is printed and actually what the data is that you're finding. And this is also a rounding thing. That's also for consistency. And then I suppose you can calculate separate pervious and pervious runoff. I never do that. I just do it the standard SCS way. And then this is a design feature. It's analogous to it's analogous to one of the settings in HydroFlow, where it will actually change the geometry of your different features that you install into your model. I don't use this either because I like to control what goes on rather than having the computer do it. So basically, to recap, we've got TR20, these boxes you need to look up. Rainfall, we have 2 different storms saved. If I click back to the 2-year, it'll display my 3-inch depth. Time span, you can omit irrelevant hours from either side of your peak hydrograph. Reports is how your data is displayed. Unit hydrograph, you can choose which one you want. Advanced, set it to 5. IA over S ratio you can tweak, and I always check these 2 boxes. So I'll just hit OK. That sets my global settings for the model that we're going to do. Now, to start building your model, you have 4 features that you can install on this in the model that basically comprise everything you need, and each one of them is independently editable for whatever features you have on your site. So subcatchment is more or less a drainage area, and so all you do is you drag these things in, basically, but I'm just going to start with one at a time. So you can edit these. Since Mark says the double click's broken, I'll just use the right click so it pops up the menu. And I'll go to edit. We'll name this. The general tab is where you name it. Area. I'm just going to make up some stuff real quick so as not to belabor the point. And I'm just going to put 10 acres. For CN, it's nice because you can click and find whatever your CN values are from this table. This should match TR55, although I haven't cross-checked every number. I'm going to do a post-development model here. So we're going to do quarter-acre lots on these soils. The next feature on this is large areas. You can either express this in square footage or in acres. So that's your choice. I tend to use square footage because when I click on a drainage area in CAD, it always displays in square feet, and it's just one less conversion I have to do. So we'll leave it at acres here for now, though. TC, it's as simple as double-clicking, or maybe not. It's as simple as hitting Edit TC.
Double-click is goofy when you record. I apologize.
Okay. You can either do a direct entry if you want. I haven't. Like a lot of these options, I haven't used every single one, but I've messed with it a little bit. Probably the thing you'll be most used to is just the traditional way of entering sheet flow, shallow concentrated, and channel. So we'll just go to sheet flow. Okay. We'll just call this 1. Surface description. I'll just pick one. Dense grass. That automatically puts in the Mannings. I assume you can make this independent of that if you want to. There's probably a custom, thing. You can just change it. Okay. Flow length, we'll call it 100, and then that's already set. Or no, it's not. Sometimes that seems to import from the global settings, and sometimes it doesn't. I'm not sure exactly why. Land slope, we'll call it 5%. This is in feet per feet. And I haven't actually explored what use common P2 means. I assume it refers you to the TR55 worksheet number 3. So maybe that would explain what P2 is. But like I said, before you start using this, you need to know what the checkboxes are.
The common P2, I believe, is if you do a multiple lengths of sheet flow, we use a common.
Okay.
Right. So if you do 3 more, it will, like you have the 3 under here, you in the next one, you hit common, it's going to put 3 in.
Okay. All right. So I'll hit OK there. That pops it up there. Do another one for shallow concentrated. Okay. Cancel. There we go. So that'll be segment 2, surface description, unpaved. That defaults. Base flow, call it 500. And slope will be 0.03. And that's okay. And then we'll do a channel. And for channels, you can do circular channel. That will be a pipe. The caveat is that this only does open channel flow. There's no pressurized flow or anything like that in this program. Parabolic channel, whatever. We'll use a parabolic channel for the purposes of this. And that'll be segment 3. Top width. Flow depth, we'll call it a foot. Channel slope, 2%. Manning's in, it's nice because you can look it up, and I think most people tend to use the clean straight bank. There we go. So then we'll just use the mid-range value for that, and you can tweak it over here with these arrows. Flow length, we'll call it 1,000. Okay. So that's our TC notes, are just any notes you want to appear. Like if you have something particularly special about this drainage area that you want to make note of, you can enter it here and it'll show up on your printouts. So that's how you make a drainage area. That's our drainage area 1. One of the nice features is that you can copy drainage areas. So I can copy this and paste, and then you just move, and we'll rename it to 2. You'll notice that all your areas stick, your time of concentration sticks. So now we have a 2 drainage area project. The next step will be to do a pond or a basin, whichever you like to call it. So you just drag it in, and in order to edit, you right click, and you're editing the local features of this pond. So we'll just go to edit. You can name it Basin 1. You can specify the type of pond this is. I don't know what you would use none for. I have no idea. So I've never used that. You can model it as a catch basin which has no storage whatsoever, and I guess that way you may be able to simulate like a road crossing, whereas you can effectively say, well, this is an outlet structure. You can set up parameters for it. You can run some water to it, and it won't act like it stores anything. It will run just like it may be a culvert crossing would. That's the best explanation I can come up with it. But the good thing is this has a very nice help menu and a really good website. So if you have cause to use that, you can look it up on there. This button is just your run-of-the-mill retention pond, like you've always seen. Storage, you go into to this, and
Hey, can I make a comment on that pond catch basin?
sure.
Well, we just had a project where we're doing in-ground storage, and this program works well for that because you can set the outlet for that catch basin up as your culvert, and it'll calculate the storage that's available in that pipe, just like in a detention pond.
Okay.
There is a lot of things you can do in here. We haven't had anything else to design our conveyance systems with for the last 2-3 years, and we've been using this program to do that. There's a lot of things you can do with that that spawn set to a catch basin. There's also an infiltration factor available. You can set that in there as well.
Okay. All right. I guess we've been spoiled here with HydroFlow, so we haven't had to use it for conveyance purposes.
I agree that HydroFlow is going to be easier to use on conveyance. I can see that. But with the new BMPs that he's pushing here and calling for infiltration of the 2-year volume and all, I think this program is going to be very valuable in trying to apply some of those principles.
I agree.
Okay.
Clarify, you're saying we do all the offices have 450 nodes available?
Yes, all the offices have 450 nodes.
All right. We'll move on to the storage part of this. Again, you can either use large units or small units. I'll just use large units here. Actually, no, I'll use small units. Edit storage. This is where you would specify if you wanted to do underground storage, or you specify the shape of your chamber, basically. I personally use custom stage data. This would be a type of vertical cylinder if you happen to have that, underground or above ground, potentially, I guess. Horizontal cylinder would be a pipe. Parabolic arch would be like the doghouse type systems you may see, where I guess you have the open bottom and then it's just an arch and you pave over it after you fill. Prefab chamber, I would imagine that you can really customize the shape of that. So we'll just go to custom stage data for now. You can embed objects inside, like if you get a reviewer who insists that you account for your trees that you have to plant in the basin, you could potentially put that in there. Storage multiplier, and this goes for all nodes. The storage multiplier is just, you can set that to 0 if you want to simulate no storage, if you want to see what it looks like without your basin. Not sure if that still interacts with your outlet structure or not. I've never done that for a basin. I've only done it for, what was it? I've only done it at the outlet structure to simulate like an emergency block condition at the 100-year storm. Voids, you can set your percentage of voids, and that'll subtract a certain amount of volume from your basin. Surface area is what I typically use. You can also use incremental storage or cumulative storage. Surface area, I usually just click on the contours in CAD and enter the surface area from CAD. So, let's see. Yeah, I leave the checkboxes as is. I'm using small units, meaning square feet. So at elevation 800, we'll have 5,000 square feet. And the handy thing is you can tab. 801, we'll do 7,000. Okay, so we'll just go with that and see how it works. Mark, do you know what the shape? I mean, is that if you enter stage data? I don't know that you would need to really use these settings. Have you played with that, Mark? Okay.
Brian, you played with the shape?
No.
So that's another thing you can experiment with.
Like Eric said, we're by no means experts.
Right. And if I'm going through and I say something like I haven't used this, and somebody has on the call, just go right ahead and give us an explanation. So I'll hit OK here. That shows up here. All of the information I just entered is embedded in this line, and you can put multiple lines up there. I personally have only done run-of-the-mill single basins. And I'm sure there's an application for doing multiple lines. Maybe that's multiple storage chambers, and you can have maybe you could have the subcatchment run simultaneously to your multiple storage chambers.
Right. If you have like a pond, if you have a detention pond that was partly above ground and partly below ground, connected by a horizontal pipe so the water could flow evenly in between any of them, you would do your above ground storage. And then, just throw me the mouse, just do it now. The below ground storage you would enter in here. the below ground storage would maybe be off to the side. What you would do for the horizontal prismoid, you do prismoid. This would be the rock. So say the, let me just say rock bed. Would you say 800?
800 was my invert.
Yeah, so it's going to be the same invert as the basin. It's not embedded in anything. It's the side of the basin, like underneath the parking lot where the basin would be, you know, at the edge of the brick wheel. The bottom width, let's do 100 by 100. And the height, and you said, let's make it 4 feet. And side slopes, I just make these 100 because the rock's going to go straight up. You can't do exactly straight up, but I think that sets it off in 4 feet, 100. It's like a couple hundredths of an inch. You're not embedded in anything yet. You only have one chamber of rock beds, and your porosity is 40%. Sorry, void space is 40%. And this is important down here when embedding storage chambers. Enter the outlet. Enter the outer storage first, volume first. So that's why it was important I entered the rock. Now I can go to this level. I can do prefab chambers. If I was using another brand that wasn't in the prefab list, I'd use these parabolic arch, and I can define it myself. Prefab chamber, I'm going to call it StormTech. Those have to be half a foot above, so it's 800.5, minimum half foot up. I'm going to do a length. We did what, 100 by 100, so I'll do 90, 5. I'm going to pick my, Caltech was the other manufacturer. No, I can't remember what I said. But there's 2 types of chambers in StormTech. You can go to their website, just look it up. If you do use those, or the Caltech. This is, you know, the prefab part is basically just giving you this automatically for you. It's telling you all the dimensions of it. And it's, you know, the people who make the chambers got in a little deal with HydroCAD for them to put it in there. This is the important part. This is where I'm now going to embed these chambers into volume 2. How do I know it's volume 2? 2 is my rock bed. Can view the chamber if I want. And void space within the chamber itself is hollow. It's 100%. And there you go. And that's underground. So now you have above ground storage that is connected somehow with below ground storage, maybe right beside of it, like underneath the parking lot side. You can imagine a parking lot draining down, and then parking lot ends, and then you have above ground storage, and then, you know, it's underground underneath the parking lot. And then the prefab chamber is embedded within the rock bed as hollow space. That's correct. Correct. And when it does your volume, it does the stage storage volume from the bottom up. It takes into account the above ground, the rock bed, and the storage chambers. And you can do more stuff if you want. That's how that works.
Yeah. Okay, so we'll move on to outlets. And then I don't have anything preset, so I'm kind of making this stuff up, and my basin may blow up, but hopefully not. So this is very similar. It's analogous to the way we just set up our storage. There's one very important thing, and if we look at the agenda, I even put it in bold down here. You must put all your subsequent routing to your primary outflow culvert in order for this to work right. And I'll explain what that means. The first structure we'll define is going to be our primary. It has to go on the first line. And we'll do edit outlet. I'll pick culvert. Okay. That defaults to the bottom of my basin. Discharge multiplier. As I said before, if you say, all right, well, I want a 2-barrel culvert, you can change that to 2. If you say, all right, well, I want to, once we put an emergency spillway in, you can say, well, I want to see what my condition is during the 100-year storm with a block outlet structure. So since this is your primary outlet structure, you can change that to 0, and it will block all outlet structures which outflow through this, meaning it'll block off all the orifices or the great inlets or whatever else you have. But for right now, I'll just do number 1. And this is your pull down where you check to make sure you're using primary. And this is a little message box that comes up and tells you about what I just said. Culvert, what does that say? Outlet invert, we'll say $7.99. Length, we'll call it 50. Slope, it calculates. Mannings, you can have your handy lookup thing. I'm just going to put 0.013. And then this is basically like an HY8 value. And we'll do corrugated plastic pipe. I don't know of a situation where you would have something other than a square edge head wall unless you had just strictly an outflow culvert. Most pipes in the box are going to be a square edge head wall, so that sets your coefficient. There we go. Diameter. I guess you could do a box culvert. I've never seen a box culvert outlet structure, but you have the option. This, I'll just put it as a 24-inch pipe. When I hit OK, it puts it in there. It's the primary outlet structure. It's device number 1. All structures we put subsequent to this, with the exception of the spillway, are going to be driven into this one. So that's a mistake I made when I first started using this, and it gave some weird results. We'll do orifice grate. Okay. You can do a horizontal plane. That's your grate, like an M-top inlet. You can do vertical plane. I'll just do one orifice. You can set your discharge coefficient here. For the horizontal plane, you can also, it defaults to use weir flow or at low head. So that's a setting I like to use. And I actually think what it does is it uses the more conservative of the two values. So it'll show the greater flow between orifice and weir flow over the horizontal. Diameter, we'll call it, 10 inches. Discharge multiplier, you can have, like this is handy for E&S if you have a row, like a pipe riser, and you have a bunch of 1-inch orifices in it. You don't have to put in every single one. You can say, all right, well I have 10, so, or whatever the case is. You can change that value to reflect that. Also, you have rows, and you can set the spacing between the rows. Also handy for E&S, but we'll just leave that as one right now. The routing is that's the important part I was talking about. You don't want 2 primary outlet structures. We want to route this one to device 1, and then it's another dialog box which you can read at your convenience. So that one's good to go for now. And I set the invert correctly. Then we'll put in an emergency spillway. So that is going to be, where is that? Broad crested rectangular weir. Okay. And this is going to be secondary flow. That means it's separate from the primary flow if it ever reaches that water surface elevation. Invert, does anybody recall what the top of my basin was? 804. We'll call this 803. Crest length 20. Crest breadth 8. Crest profile ID. You can pick a number of these, and they're customizable. You can set the C value, and I don't know, Mark. Do you have any further comment on what exactly this does?
No, I don't know.
Yeah. So this is something.
I use what it pops up automatically, and probably need to look at it a little further.
Right.
I think you can customize it if you want. I think I look at that as like, unless I know what I'm doing and I have a specific reason.
Yeah.
If it's telling me a broad crested weir has that, Peter Smart's a lot smarter than I am.
Okay. So then this is discharge multiplier. You can have multiple spillways if you choose. These are the default values that it pops up. So that's settled for this particular one. Basically, we've got our outlets built to the basin. We have the primary culvert, the orifice that's routed through the primary. See, it says device 1 there, and this is device 1. You can have as many, well, I'm sure there is some limit, but you can have theoretically as many devices routed through the primary as you want to. So you have all your different orifices and your rectangular orifices or whatever. You also have your weir as your secondary spillway. Next thing you can do is set your tailwater. And in most cases, you'll use a free discharge. What's nice is if you have a major river, for example, that you're discharging at lower than the mean elevation, you could set that, and it will basically take into account the tailwater.
And just to reference back to that, if you go, remember in the general settings, we did incremental stage trans. So if you have a major river and you do it that way, what will happen is your basin won't start to discharge until it gets above that elevation. If you go to dynamic, it will actually show you the water going back from the river into your basin. The dynamic allows it to flow bidirectional. The stage trans only lets it go one way. Stage trans is how you do hydraulic grade line, basically. You go from bottom up and that's it. It doesn't go back and forth. It's one shot and done.
So I guess dynamic is like a mini heck rise almost. It probably balances the energy equation between the two.
Right, and it can take a long time to run. It's much more complicated, but it's much more realistic if you have those kind of situations. And it can save you, because if you have bases going back and forth, you're increasing your peak. And
Charles, are you going to touch on how you set up, or just explain that you can set up the exfiltration, infiltration on your outlets?
I meant to do that essentially on my agenda. We'll go down here and put some exfiltration in, just to show. Somebody mentioned BMPs on here. This is how you would do an infiltration BMP. So we'll go to line 4, hit edit outlet, exfiltration, okay. You can set where this flow goes. Discarded will probably be the default setting that everyone uses unless you have some sort of collection system. Like Bill had an example for one of his casino projects where he was collecting infiltration in a 4-bay into perforated pipes and then discharging it into the main basin. That would be a situation where you might want to use something other than discarded. You would route it through an actual structure that you would put in. But for our purposes, we'll just say discarded. Discharge multiplier, it is what it is. Velocity is your infiltration rate that you get from your geotech consultant. We'll just say an inch per hour. And I have done exfiltration before, but I don't recall off the top of my head what the various settings here mean.
the surface area is going to look at the surface area of your basin and exfiltrate throughout it. The horizontal area is just going to look at the horizontal areas. It's only going to use the bottom of the basin, where the wetted perimeter is going to use the wetted perimeter. So that's assuming it's coming, it's exfiltrating out the sides of your basin and out the bottom.
Yeah.
Typically, I would use horizontal.
So the difference between surface area and wetted perimeter, I guess, would be that with surface area, it's only the area in plan view. Allow exfiltration at all elevations, only above invert. You can set that as necessary. So that's exfiltration in a
One
nutshell.
thing I want to add is if you are not discarding the outflow from the exfiltration process, then it would be your tertiary, or if your main outlet structure is your primary, your spillway is your secondary, this would be your tertiary, then it would be the third outlet.
Okay. Yeah, and when your flow is discarded, it's not taken into account anywhere else. It just disappears from your system. Okay, so now we have 4 aspects. That invert can stay at 0. Tailwater recovered, you can set your fixed elevation. Below headwater, I'd have to explore what that means. Advanced, you can set in your basin, you can set various parameters, like you can set a base flow, which is CFS. Like, for example, if you had groundwater seeping into your basin at a controlled rate, it probably wouldn't be the most desirable thing, but let's just say you did. You could set that you're going to have so much flow flowing through the basin at any given time, and it'll add that flow on top of whatever else you have running into it from your subcatch. Starting elevation, if you have a wet pond, that's what that's for. You just set the elevation of your wet pond or groundwater elevation. Flood elevation only affects the warning messages. There's nothing is incumbent on the flood elevation as far as calculations goes. automatic base flow, not sure what that is. Finer routing is a feature that I haven't really explored. It allows you to put a finer point on your results. And I guess you can lock all these values. As usual, I haven't expanded or played with every single feature in here, and this is one of those cases. Notes, again, you can just write notes that you want to. If anything, you could specify that this basin has an infiltration rate of 1 inch per hour, or for your WQ and REV values, you could specify how much water volume is actually exfiltrated through this particular basin if you wanted to include that in your storm report. So we'll just hit OK. We have our basin set up. This red circle represents secondary flow. This blue circle represents primary flow. I'm going to route my subcatchment to this, and this is going to be my bypass. So the third thing we do is use what's called a reach. And a reach has a variety of purposes. You can have a kind of what I refer to as a formless reach. It has no real physical properties. And in that case, it's just simply a node for deciding or for comparing peak flow to post flow, or just determining what your flow is at any given point.
Sort of a point of interest almost.
Right, your study point, decision point, point of interest, whatever you choose to call it. It can also be used as a channel to add time or to account for flow down a watershed. One caveat, if you use it as a channel, it's entirely possible to have channels within your drainage area that are accounted for by the TC that you enter, because that's, if you remember back, we entered channel flow into this drainage area. An example of what you would use this as a channel for would be something like if you had a road culvert and you wanted to, represent that. That's sort of separate from your TC. I don't know, maybe that's a bad example, but
That's a great example, actually.
like if you had a divided watershed and then all of a sudden it went under a roadway or through some stream, which there really wasn't a contribution from that area of the stream that your reach was running through, I think that would be appropriate to use that as a channel. I have an example here at the end where we used them as that. So anyway, we will route our primary flow. We'll also route our secondary flow. We'll route our bypass. And then we'll just go into edit it, and we'll call this study point. This I'm going to make a formless reach, so I would use reach type none. You can also do circular pipe for a culvert, channel, parabolic channel, anything you want to. Sky's the limit in this case. And you'll notice that when you check through, your tabs change up here, so you'll have to input parameters for your various type of reaches that you choose. Like this will be your pipe diameter, this will be your top elevation and bottom elevation, landings end, etc. I'm not going to go into too much detail. For our purposes, this is just a dummy point to determine what our flows are. So I'll hit OK. And then I guess the next thing to do is show you how HydroCAD shows you what it's doing. It actually calculates all this whenever you double click on a node. So there we go. Yeah, that's our study point. It shows inflow and outflow. This hydrograph is nice to look at, but really it doesn't give you very much information. It's kind of it's kind of a nice thing to put in the storm report just to give the reviewer a quick visual, but I tend to use the summary page more. And summary page gives you inflow area, which is 20 acres. That's both of our drainage areas, bypass and basin. Gives you inflow, outflow, and as the complexity of your reach changes, it will give you more data. And this is your message box. Any warnings that come up here, you'll have to look up separately. The red warnings are really bad. Yellow warnings are just a little bit bad. Green warnings are just status, basically. And
What if you click on that? Show the yellow. Yeah.
okay, anytime you have a question mark that appears, you can click on that spot and it will tell you what it's talking about. And that happens a lot. I mean, this is a really good interactive help menu. and it's very topical. Whatever you click on, it will bring up information about that topic instead of just taking you to the generic index. So that is that. And one example, one thing I wanted to show, I'll just click on this again. Come on. You can also click on Report. We'll go to the summary page. And if you pay attention, one of the really nice things about HydroCAD is that it changes your values in real time. Like if you notice, this is 12.29 CFS coming from our study point. If you go up here and change the storm to the 5-year, it changes to 22, so it's instant. You make changes in your model and they're instantly shown at whatever particular point you want to look at. And the same can be said for the basin. The other option of double-click, rather than double-clicking, is go down to Report and hit that. And this is the graphical part. You can do a table if you want to. You can shrink the table. That decreases your time increment. And I tend to look at the tables more than the graphs. But the summary is by far the most useful thing in any of the displays. And what I'll do is simultaneously display the basin. Where did that go? Okay. There we go. Yeah, the only complaint I have is that it layers windows on top of each other.
You should be able to say never go back.
Yeah. And who knows, there may be a feature like that. So that'll show the whole watershed. This dialog box is showing for the Basin 1. This is our study point down here. So you can see that it shows you a variety of information. You have the inflow area, inflow, outflow. Discarded is our infiltration. That disappears from the model, primary and secondary. Our flow hasn't reached the secondary elevation yet, so that's 0 CFS. And it gives you a peak elevation, which is really nice. That's a value I use all the time. And like I said, when you have a question mark, you can click on anything, and it'll say, all right, well, you want to know about the pond elevation summary. Here it is. I've learned a lot just by looking through the help menus. Let's see. This gives you a summary of what each of your outlet structure is doing. This is your stage storage data, and this is sort of another summary of what each one is doing.
I think the first one is storage, isn't it?
Is it? Okay.
Yeah, the first, go back up a little bit. Right there, that's a summary of your storage areas.
Okay.
It's prismatic, and has the chambers. You know, talks about the.
This is what each of your outflow structures, what their characteristics are. There's no performance data here. The performance is down here, and that shows you what each one is doing. This gives you routing, like that's discarded outflow. That little arrow shows that it's routed to it. Here you have your primary culvert. Your orifice is routed to the culvert, and the culvert is routed to primary outflow. It's kind of a little bit confusing because this is all, the culvert is classified under primary outflow. The primary outflow word up here isn't an actual structure. It's just summarizing what your primary outflow is. Down here you have secondary outflow. You can edit on the fly. Let's say that I want to increase the size of the orifice. I just click the edit button down here, and I'll go down to outlets, and my orifice, I'll edit that. Instead of a 10-inch diameter, I'll say it's a 20-inch diameter. And when I hit OK, and then OK again, watch your value down here, it's going to change. So that increases the flow down there. It's really quick, which is why it's nice. Let's see what's next on the agenda. This is our basic SCS model. Oh, links. I was going to cover links. Hopefully someone in the room here can chime in better than I can about what a link does. I know it as something you would use to import a hydrograph from another file, or something where you would want to input your own hydrograph. Like let's say you have, I don't know, a decorative fountain that's always going to pump 10 CFS into your system. You can specify a hydrograph to always show that is going to be inflowing into your system. So you just drag it in and you edit it just like all the other nodes.
Some other things a link can do is if you want to connect two HydroCAD files together, like you do half the design in this because it's 450 node limit, and you do half design in the other one because it's 450 node limit, you use a link, you connect the two files together, you got to run the one, it's going to only have that data from that link, but then the other one will automatically use it. But it's not like they'll dynamically work together through the link. There is that restriction. It's basically if you want to do, like Charles said, and if you want to get data in or out of the file, you use a link.
Or a user-specified hydrograph, which is probably what I would use it for. I try to keep everything in one file.
Yeah, I've never used it for that, but
Right.
I mean, I've used it when you're, when there's an existing pond and you have someone else's report. Maybe you're working next to another development, and instead of re-engineering their pond, you just want to use exactly what the report says their outflow curve is. You can use that here.
Let's see. The caveat to all of this, well, maybe not for SCS. I'll take it back. I generally try to keep one study point per file because it's just simpler that way, and that becomes more important in the rational example because it's complicated. We've been talking about this for a while, but your storm duration is dependent on the multiple watersheds and their characteristics that you have embedded within your rational file. So when we do a rational example, I'll show that and why that's important. And that being said, unless anybody can think of anything else to say about SCS, I'll just go over rational.
Why not TR55 routing? Isn't that what some municipalities call for?
TR55 is TR20 simplified, and then once computers came of age, you don't need TR55 anymore. If they require TR55, I would ask if you can use TR20. If they know, I mean, they should let you use TR20. TR20 is actually SCS. TR55 is just a tabular method generated from, TR55 is a tabular method generated from TR20 because you have to do it all by hand. So that's why computer programs always use TR20 because it's the original method and calculation intensity doesn't really matter. As far as I understand, does everybody else?
Yeah, I agree with that.
TR55 looks at a shorter storm. It doesn't look at the entire volume of the hydrograph. I think it starts at like some portion before the peak. It's more for looking at peak elevations, but I think what Mark is saying is right, is that it's the same methodology, it's just, it was a simplified version that sacrificed accuracy for your storm volume for quickness in doing hand calculations.
So you could probably set your duration. If they really wanted to stick with that, you could probably set your storm duration not to look at that.
Not to look at starting at time 0 all
Right,
the way to
right.
the end of your duration, which gives you that full volume under the hydrograph.
What he's talking about is going back up here to your global settings to the time span, and then you could set your start time and end time to emulate TR55, whatever their start and end times are. Like I said before, this is what it actually uses to calculate. The reports tab is the time it actually uses to report, so you can reduce pages in your storm report. Like if you have, 1/100th of a CFS for 10 hours, then you don't really want to show that in your report. And so moving along to rational method, in theory, you are supposed to be able to switch between rational and TR20 by going up to your global settings and just simply changing this checkbox. Now, I've seen it work and I've seen it not work. The key is just converting your your runoff coefficients or your curve numbers to runoff coefficients. That's kind of the linchpin in the whole process. So I'll see if it works. So we'll just switch to rational here. You notice some tabs change. And I'll just go and hit OK. Yeah, duration can't be less than 1 minute. That's fine. We'll set all that up in a minute. Maybe not. All right, so it's locked it up until I set a duration. So I'll go ahead and show the global settings for rational, and we'll hope and pray that the curve numbers have converted over correctly to runoff coefficients. So we'll start with the general tab. Like I said, we switched it to rational. These are still the same ways you model your basins and whatnot. Rainfall. This is where the IDF curves come into play. I'm going to pick region 4 just because that's where we are. You have different IDF events that are taken off the curve, and that'll be a 5-year. We'll just call it that. Intensity. Okay, this is where it starts to get complicated, because if we had one drainage area and one basin, just like you would model with VT Push'em, you would set the duration to equal the TC of your drainage area. And I don't recall, I don't know, what, is it
15 point some minutes.
All right. So we'll call it 15 minutes, and that automatically pops up an intensity that is dependent directly on the IDF curve that we have. And you can see the IDF curves here if you want to. Go to the next tab, time span, start time, end time. A lot of times your rational hydrographs are much more abbreviated than the SCS hydrographs, so you can play with this. Time increment defaults to 0.01. You can change that for more or less precision. Reports is just how it's reported, same settings as the SCS method. Rise and fall, that's actually a very important thing. But what this defaults to is traditional rational method, where you have 1 times the TC as your storm duration. Now, if you want to emulate VT Push'em, which is what I advocate for, you change this to 3, and you change this to 7. Because what the programmers at Penn State have done is decided that this hydrograph shape, I guess it represents an actual storm more closely than what the traditional rational method does. So what this does, at the end of the day, this increases the volume under your rational hydrograph and makes it more realistic. And it's about as close as you can get to SCS without actually having to do SCS. And this checkbox shouldn't come into play unless you run a critical duration analysis, which is something I'll get into in a minute. But to be conservative, I would always check this box. You can't go wrong by checking that, and you can hypothetically go wrong if you don't check it. What that does is if your storm duration doesn't allow one of your subcatchments to reach its peak, it actually extends that hydrograph out and includes the volume that it would have had if it did reach its peak. So anyway, getting a little deep here, so I'll just move on.
What if you go back there and hit the set defaults? I think it keeps that then.
Will it? Okay.
I think that's. Oh no, it's going to go back to the original set.
Okay. So we'll do 3. We'll do 7. Maintain.
And I'd like to underscore Charles' comments on that, how important that is, this setting right here.
I'll do an example at the end which shows how drastic the difference can be if you change these around. But at the end of the day, if you just want a simple rule of thumb, 3, 7, and check. That's all. I wouldn't deviate from that unless you know why you're deviating from it, to be honest. And of course you don't have to take my word for it, but that's what Penn State does, and I think that's what we should do. Advanced setting, you can set a minimum TC. That should be set to 5. And this is also the same as an SCS, the 2 checkboxes. This is also the same. You can opt to resize your various facilities that you put in there. Like I said, I wouldn't do that. I like to control what happens. So those are all the global settings that have been added. We'll just hit OK. And let's see what happened to the various boxes that we had here. I'll close those out for now, and we'll bring them back up in a minute. So what I'm going to do now is check to make sure it converted. And it didn't, because these are all flatline now. We should have some runoff there. We'll go to the Edit tab, and it kept the area, 10 acres, and it kept the TC. Now the website says you can convert between the two, but as you can see, it didn't convert over the C value, so we'll have to do that manually, which is fine. So we just click there. Click on the C part. Oh, right here? Okay, there we go. And,
Look up rational. Here you can get it. It doesn't have a default.
oh, it doesn't have a default? Okay, well, we'll just call it, I don't know, 0.85. Is that reason?
You know why it doesn't have them? Because it knows it's bad.
Yeah. Yeah, as a general rule, use FCS, but that's, you know. So that's that. TC is the same. That's stuck. We'll hit OK. You can see the hydrograph is a different shape. So we'll X out of that, and we'll go over. Now, if you're doing traditional rational method, what you would have to do in order to do this correctly, assuming this had a different TC than this, you must go and store these in separate files, because what it will do is it'll impose a storm duration on this that deviates from TC for each subcatch. And that's a mouthful of words, but if the general rule of thumb to take away from it is that any time you have a different TC for an area, you go and you store it in a separate file, just like you would VT push them, and then you could either bring that data in via a link or some sort of other way, or you could add them manually and add peaks as if you were just doing VT push them. But there is a feature on here that you can use to make an aggregate storm duration, and I'll explain that in a minute. But first, I'm going to change the values for this particular subcatch. So, area of the C deviated. I don't know, we'll call it 0.7, and area I can leave it the same. I'm going to change the TC because I don't want these TCs to be different. I want to be able to show you guys an example of why you would use critical duration. So I'm just going to go back to, I guess sheet flow will have the biggest effect on it. I'll edit that and change my length to, I don't know, 50, and we'll see what that does. So that drastically reduces the TC. I guess that says 11.2 down there if I'm reading that correctly. So we'll hit OK in that box. And if we go back to this one and look at what our TC is, go to the Edit tab. TC is going to be 15.5 for that one. And if you remember from stormwater class, anytime you have rational method, you're not supposed to combine hydrographs because you theoretically have different storms raining over the site simultaneously, because the storm duration and intensity is directly dependent on the TC. So, like I said, if you were doing traditional rational method, you would separate this out and have a separate study point for it, and then you combine those manually or through a link. But what I'm going to show now is, I'll just delete this one because it could potentially be confusing. What I'm going to show now is what we call the critical duration analysis. And opinions vary on how to employ this feature. I'm just going to show you what it is and that it exists. And if you have any questions, depending on who you get in touch here with Harrisburg, or depending on who you get in touch with in our office, you'll get a different opinion on how to use it. But there's not yet a consensus on this.
In fact, we would welcome any input from others within the company.
Exactly. I mean, we're not Moses coming down the mountain with the tablets necessarily. So if you have any ideas, feel free to interject them. But the way I personally do it is I will click on this tab, and of course I can't double click. There we go. This shows our inflow CFS, our outflow CFS. That's 11.92. Remember, this is a formless reach. It has no physical characteristics to it. And behind it is our message box, which would pop up warnings if we had them. All right, so what I'll do, the way you run critical duration for any given node is you go over to the duration tab. When you hit apply result, that applies your duration upstream to every node that's upstream of that point. So what it's going to do, what HydroCAD actually does, is it holds the time of concentration from this watershed and from this watershed, and it runs varying duration storms over the entire site. And what it will do for a reach is it will calculate which storm produces the highest peak flow at that reach. What it does for a basin is determine what duration storm produces the highest water surface elevation. And what it does for these subcatches is pretty much just give you a TC, because, well, that's just what it does. It emulates the traditional rational method when you run it for that.
And this is more of a question. My understanding is what it's trying to do is, rational does not have a volume, does not give you storm volume. So it looks at all the possible storm volumes by stretching out the duration and gives you the worst case scenario. Accurate? Is that what it's doing?
And a reach gives you the worst peak flow based on the combination of those
But it's making up for the shortcoming of rational not giving you a volume. Is that
I-
trying to,
Like I said, we differ on opinions of what this
Well, I'm asking.
Yeah. The way I see it is that it tries to leapfrog over the limitation of rational, that you can't have simultaneous storms occurring with different intensity values over the same site. And like I said, that's my view. There's other views on what it's employed for. We'll leave it up to you to decide. But anyway, I just wanted to show you how to use it and explain what HydroCAD actually looks at and how it determines what the critical duration is. So you go up here, we're running critical duration for our study point, which is a formless node. What it's going to do is take the inflow from this, take the inflow from that, and as far as travel time calculations go, it's going to use the embedded TC that we entered. It doesn't change the TC from this. And part of that is the flow through the basin. So when you run critical duration here, it actually depends on the performance of your outlet structure at this basin. And, I hope we're not getting too deep here. We've had the benefit of working with this program for a long time. So like I said, if you have any questions, give me a call. But without any further ado, I'll go ahead and run critical duration. And it decided that 34 minutes was the critical duration, or it's the duration of storm which governs the intensity over the site that produces the peak runoff at this node. Now, 34 minutes is a lot different from the 11 minutes that we saw at the bypass node, and it's a lot different from the 15 minutes we saw at this node. So it is totally departed from reality, I guess you could say. But
Where does it apply that stuff? I think that's important too.
this applies, what this does when you hit apply result is it applies this storm duration of 34 minutes to this subcatch and this subcatch.
Anything upstream of where you click
Right.
to run is what it applies to.
Now, wait a second. It applies it to the general, that was a loaded question. It applies it to the general, hit the calculator.
Right, it's a global setting.
Right. So it applies it to everything in that HydroCAD file.
Yeah, if you
But
notice-
you're studying the design point, anything downstream will not affect that.
Right. All right, I'm going to cut it off. This isn't a discussion we need to have right now. But
No, it wasn't a discussion, it was just explaining that it's anything upstream from your design point
Yeah.
that is affected.
34 minutes has been put into the duration field automatically by HydroCAD. This is a global setting, therefore it applies it to every subcatchment. And we can argue logic all day long. So anyway, what this does is it goes and it references the IDF curve. And if I knew how to display the IDF curve, I'd show you what it does. But if you imagine, it uses the 34-minute duration, picks an intensity off the IDF curve, and applies that intensity over your site. And yeah, so that's what it does. And what you'll find out is, let's see, if we have our report here, our summary is now 16.49, so it changed our outflow at the end of the day. Anyway, like I said, that's what it does. That's how it works. If you have any questions, please give me a call, and I'll be happy to discuss theory with you. So that's critical duration in a nutshell. If you don't want to get into all that, your option is to separately calculate every drainage, every sub-drainage area, and that is by far the safest thing to do. It's the least complicated. It emulates VT Pushem as closely as possible, and you don't have to get into all this critical duration stuff because your intensity is your time of concentration on your subcatchment. What else? And let's see.
You want to put that on the website?
Okay, I'll do that. I wanted to do some other things before. I wanted to tell you why you would possibly go to all this trouble in order to set it up this way and give yourself this headache. When you do a BT Pushem model, you basically add peaks. You can't really logically add hydrographs. So you're exaggerating the peak flow at your study point when you add the bypass peak to your basin peak. And what you can do with this is by actually routing it the model all at once. Let's say you had 3 basins. You could have a first flush, which let all that water out initially, and then you could have a slower acting basin, which let some water out sort of midway through the storm, or just retained more water basically. And then you could have a basin that retained a lot of water, like maybe an infiltration basin, or just one with a 3-inch water quality orifice or something. So what you can do with this method is spread your hydrograph out over a much longer period of time, and it knocks that peak down. So the tangible benefit to the clients is that you basically have smaller basins at the end of the day, because you're not having to retain water independently from each subcatchment. You can let the basins act together in concert to mitigate your peak down at this point. So anyway, feel free to use it as you would use VT Pushem, or you can try to get into the more advanced features and mitigate your peaks using the critical duration analysis.